Winner. $1. Ah. All right. No. Wow. Uh-oh. Huh? Mhm. Huh. Where is this? All right. Right. Hmm. Hello. Hello. Who is there? Me. Okay. I'm waiting for William. Hmm. Okay, there we go. Where's William? Huh? Hi, Skylar.
Hey.
Can you hear me? Oh, okay.
Yeah.
Andy.
Yeah. I can hear you.
Where's William? Huh? Maybe William doesn't know. He didn't check the email. Wait a second. William, where are you? I think William didn't check the email. Maybe he doesn't know. Let me call him. Just say wait for 2 more minutes. Okay? Maybe he's on the way. Uh, okay, 1 more minute. How's it going? Everything okay?
I'm just a bit confused with matrix C and vectors.
With matrix?
Well, matrices are fine, but yeah, sort of confused.
Oh, that's weird. Okay. Okay, let's we can talk about it. So everything okay, William?
What?
Everything okay?
Like technology-wise?
Okay, whatever. Anyway, Skylar, we're okay. We continue now. Okay. Skylar.
Yeah. Okay.
Okay.
Yeah.
All right. So now let's start with the oops. Now I have some. So still start with the exercise. Okay. Let's then start with Skylar. What's the answer with this?
Second.
Check. What do you have?
Okay, I'm trying to find it. But I don't think I have that one. No.
You don't have it?
Yeah, I don't think so.
Who has it? Who has it? William have it. And you have it?
I'm looking.
Was it 5?
Huh?
5?
Yeah, I got 5.
Okay, Scott is 5. Okay. So actually
Okay.
this one is, are you okay with it?
Yeah.
So basically it's fairly easy. So like I think oops. Yeah. Brush. What? Oh. All right. So x is 7 minus 24i. You can just calculate 1 by. So this is by the definition square root of. Right? So this is 7, 24, 25 triangle. Right triangle. So 3 whatever minus plus doesn't matter actually is equals to square root of 3 square plus 4 square is 5. So whatever it is, the answer should be 5. Huh?
Okay.
Very funny. Huh. I think I should close another one. So that one should be easy too. Andy, do you have this one?
64 plus 64.
Yeah, that's
what?
why.
Huh?
64 plus 64i.
Yeah, that's what I have.
Okay, that's quick. So that one we did it. I think it's the exercise, right?
Yeah. Yeah. One of them.
William, do you remember it?
Is it just 1?
I think it's the minus 1 to the n plus 1.
Or n minus. Yeah.
I think
Yeah.
That's what I have.
it's in the book. It's
Yeah,
in the
that's what I
book.
have.
Yeah.
I don't remember what it is, but it's in the book. Huh?
Yeah.
Anyway. So that one. And do you have a scalar?
This one I have 2 minus I.
Minus I. Is that right?
Yeah.
Everybody?
Yeah.
Okay. Is that right, Andy?
Yeah.
Huh?
I think.
How did you do it?
I just kept on substituting the thing.
Huh?
I just kept on substituting the thing. Yeah.
What?
Hmm?
How did you do it?
I just kept on putting 2 plus I in. And then after that, the answer after that I got it. And I put it back in. And then I found the pattern.
You doing 1999 one time?
What?
You doing 1999?
No. After a few, there was a pattern.
By the pattern. I see. Oh, okay. So actually the key thing is we're talking about this kind of thing many times. So f of z equals z plus 1, z minus 1. So if you calculate one more time f of z, it's going to be z plus 1, z minus 1 plus 1, z plus 1, z minus 1 minus 1. So the numerator is 2z. The denominator is 2. So it's z. So essentially f twice equals the identity. So f 199110 is also z equals z, right? Right?
Yeah.
So essentially, so it's f1991. Z only is equal to f of z. Whatever this value is, that's it. Okay?
Yeah.
Yeah.
So I have to keep this. I think. There we go. How many K is a real number? Who's trying this? Andy? You got it.
K equals 0 and plus and minus 2 square root of 4.
Plus or minus what?
2 radical 3.
Huh?
2 radical 3.
2 radical 3. Okay, looks like right. All right. It's about omega. Do you remember omega?
Yeah.
Okay. Well, I should be easy. This is the definition, okay? Good?
Yeah.
We have
Yeah.
problem. Huh?
No.
It's just the definition of the slope, okay? You see?
Yeah, it's just however, right?
Actually, sorry, I didn't already draw this diagram. Let's skip this one. I thought I forgot something. Written A plus BI. This should be easy too. William, do you have this one?
It's 4.
Huh?
4.
4? Is that right, everybody?
That's what I have.
Yeah.
Okay. What is the graph of this? Skylar, right?
I have a problem.
You have problem. Okay, Andy,
A
you have
problem.
problem. Huh?
Yeah. Never mind.
Huh?
Never mind.
What do you mean, never mind? You okay?
Yeah.
Okay, what is it?
Problem.
Parabola, okay. Okay. I don't. So does everybody agree with it?
Yeah.
Andy, what do you have?
Yeah, it's a problem.
Parabola?
Wait.
Let's look at together if you're not sure. Huh?
Should be.
Huh. You don't
Should
know.
be.
Huh?
It should be circle.
Z equals to image Z. You just say Z equal whatever, right? Then it becomes Z absolute value. We should definitely know that. Okay, absolute value of Z is x squared plus x squared plus y squared. This
It's
just
problem.
right. Then you have Z image Z, which is that's A. That's the image Z. Okay. So equals to y plus y. That's all. So you have x squared plus y squared equals y squared plus y plus 1. Then have x squared minus 1 equals 2y. Y equal 1/2. X squared minus 1/2. So what is that? What is this graph? Does anybody know how to draw it? So
It's a
it's
parabola.
path. Huh? Yeah, you're right. The path x equals 0, y minus 1. Then it's open up. Then it's something like that. Right? So what is the focus of this one? What is the directrix? What is the focus? Huh? How do you calculate the focus?
I just need to get some paper out.
Okay, I give you a minute, everybody. Okay, write down send your focus to me. Okay. Yeah. Okay. Good. Mm-hmm. Really? Okay, you can go to the previous chapter to let's see together. What is the curve with the Skylar? Do you have it?
Wait, what are you asking?
Do you have it?
Yeah, I
write
think
down the folks. Huh?
yeah, I think I have it.
Write down the folks and the directions. Okay. So remember, then y equal 4a. Okay. 4a then x squared. Whatever, you don't really care about that then. Right? So a is important. So in our case, a equals to 1/2. So essentially the thing's called, so you pass that part 1/2. So here is already 1/2. This point is x equals 0 minus 1/2. So this is the 1/2. So that to be this point, be the focus. Okay? 0, 0. So here is the directions. Directions you have to write as y equal to -1. This is directions. Okay, forgot quickly, huh? Let's see what you have, guys. Okay. Andy had folks 0, 0. William, how could you have folks as 0, 1 quarter?
No, I changed it. I
Oh,
thought it was -1/4 in the beginning.
okay, you changed it. Okay, Skylar, how could you have 1/2? Huh?
Yeah, because I took the 1/2 out of like the 1/2 x squared and the minus 1/2. So I took the 1/2 out of both and just I had h as 1. I had h as -1. Wait, never mind. Wait.
Okay.
Yeah, never mind. I did something wrong.
All right. So we have to constantly review whatever we learn all of it. Okay, that's interesting. Just learn it. Write down the written cosine. Find theta is function of cosine theta. You can do either way, okay? So whatever it is, doesn't really matter. You can do like a lazy way. You can also do in smart way, so-called cosine theta plus I sine theta to the fifth. So the real part will be something plus I something. So this also equals to cosine 5 theta plus I sine 5 theta. So if you compare the real part, so here is this part, here is this part. Just expand it. Do you have problem with this? Okay, no problem.
No.
No.
Find the imaginary part of cosine. We did that one last time. Does anybody remember what it is? When did you do that, Sandy?
No, I didn't do this one.
This one. Did you do that, William?
Wait.
Hold on.
Oh, wait, I thought that was LM.
Huh?
I thought that said LM. And I didn't know what it was.
I am is the imaginary part.
No, I thought it said LM.
Why didn't I ask? Okay, so let's get back to the origin, okay? The origin. So you have z equal x plus iy. Xy a real number. Xy real number. So real part is x. Okay, this is the definition, okay? Definition.
Yeah.
This is the definition, okay? So no definition is very important. Trying to ask the question, what is? What is it? If you don't really know it, okay? Don't know it, definitely cannot do. So I am, Z is the Y. It's the definition. Oh. So for our problem is cosine 12 plus cosine 48 plus I sine 12 plus sine 48. Right? Then she asks you to calculate that thing. That's it. So Skylar, do you have this one?
I got 0.
Okay.
Same.
Okay. Okay. Actually, this one is very easy. Okay. This one is very easy. You just calculate this and this. I'm sorry. What is this? It's totally wrong. It's hard to let's start with the next page. I think there's something wrong with that. There you go. Sometimes kind of come back. Let's say cosine 12 plus cosine what is it? 48. We equal cosine 30 minus 18 plus cosine 30 plus 18. So we just expanded with the cosine 30 cosine 18 plus sine 30 sine 18, then plus cosine 30 cosine 18 plus sine 18, which is twice of cosine 18 cosine 30. So same thing, have sine 12 plus sine 48 going to be twice of cosine 18 sine 30. So then the original one is going to be equal to what? Twice of cosine 18, then cosine 30 plus sine 30 going to be equal to twice of cosine 18, then e to the 6 pi I. So if you raise 6 power, it's going to be 2 to the 6 cosine 6 18. Then e to the pi I. So e to the pi I is how many? Any do you remember?
-1.
-1, yes. So it's the negative 2 to the 6, some real number. So this is a real number. So the imaginary part is going to be 0. Okay? Imaginary part of
Yeah.
Cool. Okay. Okay, next question. Whose turn is this now? William? Oh, William. Next one. What is the xn plus 1 over xn?
Two cosine n theta.
2 cosine n theta. Is that right, everybody?
It said to find it in terms of n and theta, right? Yeah.
Huh?
It said to find it in terms of n and theta.
Where is it? Oh, in terms of yeah, whatever. Yeah, has to be that. Okay, so first off, we have to have some fun with it. So if x is a number such that x plus 1 over x, we actually learned that if x is real, then this is going to be at least the twice of, this is the basic average, the arithmetic average and the geometric average and the inequality, right? Which is 2.
Yeah.
So if this is if, right? But now we have x plus 1 over x equals to 2 cosine theta. In general, this one is going to be less than 2. Okay? So that means x is not real.
Yeah.
So x is not real, you can think that x equals something cosine theta. Actually, it's just exactly sine theta. It has to be that way, actually. So that x1 over x, So actually you find the solution already. So that actually is the solution. Is the solution of that x plus 1 over x equals 2 cosine theta. Understand?
Yeah.
This one is actually has two solutions. The solution. You don't really have to think that way at all. You can just by brute force solve that one. Okay, solve it. Then you have x squared minus 2 cosine theta. If you see a quadratic equation, you want to solve it. Okay, so you solve it, you get x equals 2 cosine theta plus or minus of this is 4 cosine square minus 4 divided by 2. So you see that cosine theta plus minus sine theta. Right? That's exactly the two solutions. Okay, if you know the solution, now ask you to calculate xn plus x minus n, you immediately get cosine n theta plus cosine n theta. So the imaginary part is cancelled. So whatever it is, that's the solution. Okay. Question?
No.
No question at all, huh?
Nope.
Okay. Next. We did that one already before. Okay. Who's running this? The Skylab run this time?
I have 6 7s.
6 7. Cool. Is that
Same.
better? Huh?
Same.
Andy, what do you have?
I didn't get this.
Okay. No problem. Right here, actually. So that one should be. I did something again. I always think this one. This one is the whiteboard. And I don't really have not. I'm not separate to using the whiteboard yet. Unfortunately. Is the Photoshop? The Photoshop. Is that Photoshop? Yes. Okay, this one should be fairly easy. You want to calculate sigma n equals 0 sine 2n what? N theta. N theta 2 to the n infinity. You want to add another part. Sine n theta. So that one is the real part. So that one is the imaginary part. So that one equals to sigma n equals 0 to the infinity, then 2 to the n. So cosine n theta plus I sine n theta. Right? So then equals to sigma 2 to the n. Then it's going to be e to the n theta. I. Right? Is that right?
Yeah.
Yeah.
So it's going to be sigma n equals to 0 to the infinity. So e to the theta over 2. Then you're using a geometric, that formula is going to be equal to 1 minus 2 to the theta, because there is actually there is one thing we never learned. Let's give you the formula first. It's going to be equal to 1 minus small rate. Okay, so there is one thing I actually we never learned that. Right? I think it's frozen on my computer somehow. Crazy. Why? Okay, now it's back. Back. Too slow. Something wrong. For the first second. So there is one thing about 1 plus r plus r squared plus. It's going to be 1 and 1 minus r if r is less than 1. So r could be a complex number. So we know this is true for the real number. Do you have the memory there? Do you remember it?
Yeah.
So this is also true for the imaginary number. Okay, if you've never seen that, then just remember from now. Okay. So for our previous problem, we have to say what is e to the sin theta over 2. What is the absolute value of that? Okay, if less than 1, so we'll be okay. So what is it? Who knows the absolute value of this?
1/2.
1/2.
It's 1/2. Keep forward, 1/2. So it's less than 1. Okay. So now, then back to this one. So we equals to that. Okay. So unfortunately, right? So let me rewrite it. So that one equals to 1 over 1 minus e to 2. Oh, I'm sorry. E to the e. Oh, it's not that one. It's totally wrong. I'm sorry. That's written is totally wrong. Did you say it? It's totally wrong. Actually, using the eraser to erase it. Oops. Okay, we're back. We're back. Let's do one this color. That's fine. That's fine. Whatever it is different. Right? Okay. That's fine. So it's not E. E here though. This one I don't really know how to use. Yeah. So anyway, so this is e to the I theta. So e to the I theta over 2. Okay? That's supposed to be that. So if this is the real part, you calculate the real part. That's it. How could you get 607 something? So let's calculate the real part of this number, okay? So it's that probably easy enough. 1 minus, you get 2 minus, get 2 here, 2 minus cosine theta plus I sine theta. This is minus minus sine theta. That's the I here though. Okay? Okay, let's continue equals to 2 then 2 minus cosine theta square plus sine square theta. Then 2 minus cosine theta plus I sine theta. So that will be the real part, will be that one. Okay, whatever it is, you get it?
Yeah.
Yeah.
So yes, what is that? 2 minus cosine theta square plus sine theta. Who remember the numerical part? I forgot. Huh? 2
times 2 minus cosine theta plus I sine theta.
No, just the real part.
Oh, okay.
So you can do more 4 minus 4 cosine theta plus 1, then 2. So that will be it. Okay? You cannot do more anymore. That's all. Okay?
Yeah.
Okay, the next question, we already did it last time. Should we still go with it?
What was the question exactly?
Oh, let's see the question. And then suppose the coefficient of that equation is going to be like that. Oh, I'm sorry, it's a misspell. It should be A0. My administration is messed up. A0, then A1, then fix it. A0 less than A1, like this. This is correct. It's correct. Okay. Unfortunately, this is it has a little bit of problem. Oh, let's just view like this. Oh. Okay. So A0 is less than A1, less than A1, less than A1, less than 1, that's all. Let Z be a complex number of the distance greater than 1, then show that Z has to be like that. We did that one already. Do we still need to do it?
No.
I don't
No.
think so.
Huh? Who's saying I don't think so? Who's saying it? Huh? Skylar is okay?
No.
Okay. Andy is okay?
Yeah,
Okay.
mostly.
We probably forgot, huh? So, William, can you show us? Let's see the whiteboard works on that. I don't know. So, you want to show us how do you do it? You still remember how to do it?
Sure. I don't know how else going. It's probably not going to work very well, but
Okay.
But
Let's do it
I can
together.
try.
Do it together. So, you have Zn equals to minus An minus 1 Z so Z n minus 1 minus A1Z minus A0, right? So you multiply the, then you get Zn plus 1 minus An minus 1 Zn, then minus A1Z square, 0, right?
Yeah.
Okay, you also have 7. So you also have, so you plus, same thing, doesn't really matter, you plus 0, right? So plus 0 is the same as plus that Zn plus 1 thing. Why is that today? This computer is kind of weird. So you can have it, this is equal to Zn, that thing, Zn minus 1, Zn minus 1, plus plus A0 minus S1 so minus Sn minus 1 Zn minus An going to be minus 2 N minus 1 minus A 0 Z, right? Okay.
Yeah.
So essentially, this is just 0. Right?
Yeah.
Okay. So we continue with the equal, then we have 1 minus An minus 1 Zn plus An minus 1 minus N minus 2 Zn minus 1 plus A1 minus A0 Z plus A0. So the key here is every number here is positive, positive, positive. That's the key thing. So we're using that inequality is saying Z1 plus Z2. Let me write over here. So Z1, I want to so we're using like Z1 plus Z2, even plus Z3, whatever. It's going to be less than Z1 plus Z2 plus Z3. If you have Z4, then you have Z4, then you have Z4, right? Oops. Right? Whatever. So we have many terms here. We have several, one term here, one term here. So we have Zn plus 1 is going to be less than. Okay, let me write them in the next slide. It's too small. So we have Zn plus 1 equals An minus An minus 1. Zn plus An minus 1 minus N minus 2. Zn minus 1 plus A1 minus A0 Z plus A0. Right? That's the previous pad. So you take the absolute value that Zn plus 1 is going to be less than An minus 1. Absolute value is the same thing because the positive number is going to be Zn plus An minus 1 minus An minus 2, then Zn minus 1 plus plus A1 minus A0. The key is also positive number. This is the key. So plus A0. So the positive, 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 positive. So that equals to because of what? 1 is less than Z because of, remember the condition, Z is greater than 1. So which means 1 is less than Z. Right? So the first term is going to be less than An minus 1 times Zn plus 1. Right? Just
yeah.
bigger. So An minus 1 and minus those are wrong. An minus 2, then Zn. Everything goes to Zn plus 1, okay? Then then A1 minus A0 still goes to Zn plus 1. Okay? And plus A0 even goes to Zn plus 1. Okay? Something bigger than 1. So you can cancel it. So you see the term here, and here is going to be cancelled. The term here, and here is going to be cancelled. So it's going to be equal to An, then times Zn plus 1. But A is less than 1 is also has to be like that. Right?
Yeah.
Okay. So you see here is Zn plus 1. Here is Zn plus 1. So we're talking about, so everything has to be equality whole. So everyone has to be equality to make that inequality whole. right? Nowhere can be really absolutely strictly less. So everything has to be equal. So everywhere has to be equal. The equal holds. Got it?
Yeah.
Yeah.
So we learned that thing saying Z plus W less than Z plus W. When the inequality is going to hold? If what? Huh? Don't remember?
Um,
Huh?
not really.
Anybody remember it? We even did the exercise with it last time. Who remember it? Or one is going to hold?
When they're both positive?
When they're both
Okay,
the same
let's go.
sign.
Huh?
When they're both the same sign, like
Yeah. Yeah.
if they're positive or negative, or if they're or if they're both 0.
Okay, we're going to learn something in vector in a minute. So, okay, I feel terrible about it. So this is so super important thing you have to know. Okay, this is on page 90. I already said it many times. Okay, so Z plus W is less than Z than W with this is a theorem, okay? So if and only if Z equals W,
If they're parallel, right?
parallel exactly, with
Yeah.
C is something real number. Okay? Get it?
Yeah.
So essentially it's like this. This one cannot hold. So only this line merge with this line. The angle has to be 0. So it has to be one like this, another like this. Has to be the same line. Okay? Okay, we're going to learn back in a minute. We're going to talk about this thing again. Okay. If that's the case, which means everything is going to be to Z and Zn. Zn and Zn plus 1 is going to be only different from a real number. So Zn plus 1, even under the 1 is going to be only different by a real number. Huh?
Yeah.
Actually, Z only can be 1. Because Z is going to be real, then Z is greater than 1, then Z is less than 1. It can only be 1. So C is greater than 1. C is greater than 1. Then you have everything is going to be equal. Then Zn plus 1, then Zn minus 1. Everything is going to be equal. Okay, I'm not sure you got it. So Zn plus 1 and Zn and Zn minus 1 and Z and 1 only different by the real number. So Z actually essentially is a real number. So it's a real number. Okay?
Yeah.
From whatever we learn, because A0 okay, anyway, from the condition we know Z actually is greater than 1. So which means C is greater than 1. The absolute value of C is greater than 1. So you plug into the real number again, so C to the N plus AN minus 1 to N minus 1 plus dot 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 plus A0 equal 0. Let's come back to that inequality again. So that one again. So you see the first one is saying this is greater than 1. This is greater than 1. So also you have got to have everything is going to be 1. So A is going to be 1. A is 1. Also, a 0 doesn't have to be 1. Something is a real number. Oh, anyway, we don't really care. Only prove the n plus 1 equal 1. Actually, if you analyze more, this problem actually is very strict. Looks like Z has to be 1. Not only Z n plus 1 is 1. You see it? You see it?
Yeah.
Huh? Okay, let's take a 2-minute break, 5-minute break, okay?
Okay.
What?
Yeah.